So after running these numbers here, we got 8.1, 8.1, yeah, 8.13307.571.
There we go.
Great. So that is the change in y between the initial point and the final point, right?
Yeah, so that's my vertical.
But is that what they're asking for?
That's for vertical distance.
Between where and where?
Between this point and there.
Mm-hmm. So the y we just solved for is the height here above this point.
Okay.
Which means we just solved for this entire distance right there.
Oh, okay.
And we only want this distance here.
Yeah. So it's just this minus that 1.5. Or is it minus 6.6?
So you told me.
It's minus the 6.60.
Yeah, exactly. Because the initial thing we measured was height above where it started, which was down here at the parking lot.
Yeah.
And so yeah, we're subtracting this distance from this whole distance to get that distance there.
Gotcha. So the 8.13307.571 minus 6.60 equals it gives me 1.533.
Mm-hmm.
Okay.
Great.
Plug that in. What's the vertical distance? Alright. Here, let you warm up, take a breather.
Okay.
Yeah. Okay, so now we have to find the horizontal distance from the wall to the point on the roof where the ball lands.
Oh, fun.
So from the wall to the point where the ball lands. The ball lands onto the wall about right where the children are standing, right? It's about right there.
It actually doesn't. Yeah, I mean, about here.
Yeah.
But it doesn't actually tell us that distance, so we need to solve for it.
Okay. So
Horizontal distance in meters from the wall to here. Okay. So what would that look like if you drew it on the picture?
okay. Based off the picture, here I'll do this one in black. Okay, based off the picture. So this is where the wall starts, and it lands right here. So it'll be about right there, the horizontal distance. So it'll be right here.
Perfect. Yeah.
So it'll be this distance is what I'm looking for.
Mm-hmm. Exactly.
Just double mark that. Yep.
Good work.
All right. So I'm about to erase all this.
Okay.
Yeah.
So previously, we had this being the starting point and this being the ending point.
Yeah.
Do we want to change that now?
Yeah.
Okay,
This would be the starting. That'd be the ending point.
we could do that.
Okay.
Yeah. Alternatively, we could say this is starting and this is ending.
Oh, okay. That could work. Yeah. That's starting.
I think that actually might be easier because
Okay.
we don't know the speed at this point.
Yeah, that's
and
what
we
I
do
was
know the
about to
speed back there.
Yeah. So what we're gonna do is this is starting, and that is ending.
Mm.
Yeah.
Okay, so which of these variables are we trying to find now?
We're trying to find the horizontal distance, so we're gonna Yeah, I was just making sure. So we're trying to find x.
Okay, yeah.
The position.
Great.
So
And
we have
so
we have the initial velocity.
these are the variables we would use. Okay, yeah, so we know initial velocity.
We have that.
Do we know...
Final velocity? No.
We actually do know final velocity.
Oh, 0.
Because it's 0, yeah. We might not need to know that.
Yeah.
We also know acceleration is 0.
Yeah. And we know time too.
Do we?
No.
So the 2.2 seconds they gave us was only to get to there.
Yeah.
It doesn't get us down to here, so we actually don't know how long that takes.
Got you.
And so we know that time is something more than 2.2, but we don't actually know what it is.
Okay. So we won't use time.
So if we can find something that only uses these variables, then we're good.
Okay. Alright.
But we might not be able to find one. So let's look at the kinematic equations to see.
I think I got that.
Okay.
Yeah. That's v squared equals v initial squared plus 2a change of x. My v 0 plus. And then that's just like my full velocity, right?
So Vx is not 0.
My v final?
No, so the x velocity stays the same the whole time, remember? So it's never going to be 0.
My final velocity?
No, it's not 0.
It's not? Oh.
So if this is the starting point,
Yeah.
then the initial velocity in x is the x component of that hypotenuse.
Okay.
And because there's no acceleration in x, it's going to keep moving at that same speed horizontally the whole time.
Okay. So it would be this horizontal distance that we found, which is, it wouldn't be the 18.12.
So 18.12 was the speed at which the ball is launched,
Yeah.
which is kind of like the hypotenuse of the initial speed triangle.
Yeah. Would it be that initial velocity that velocity of x?
Yes.
Okay.
Mhm.
Then
I
what
think we
is-
actually erased that.
then what is this?
That's, oh, sorry, that's the initial in x. So,
Yeah. That's the v initial.
so when you see
right?
v and v naught, another way to write that is v naught is just v initial, v is v final.
Yeah.
Mm-hmm.
Yeah. So like.
So
I thought we said this was 0 and that was like that initial velocity of x.
this is the initial velocity, but why would this one be 0?
Because that's where it landed, right?
But when it lands, it's still moving.
It's still moving.
Yeah.
Okay.
So if it lands, it's actually asking about the instant, like right before it lands,
Yeah.
because once it hits something, then it's no longer projectile motion.
Yeah.
But it's asking about like right here, just like a millisecond before it lands.
Okay.
What's its x position?
Okay. So what would this be then?
It would be the same as v initial. So can you hold this for a second?
Yeah. So these two would be equivalent.
Yes, exactly.
Okay.
So in a situation with no acceleration, and remember the acceleration in the x direction is 0.
Yep.
So in a situation with no acceleration, velocity doesn't change.
Okay.
Which means this is the same as this. So all we get here is vx squared equals vx squared. And then a is 0. So it's just this.
Yeah.
And unfortunately, this means we can't solve for x because this whole term became 0.
Yeah.
So we're going to need a different equation.
Gotcha.
Oh,
We're gonna have to
we
solve
should
for
freeze
t.
here. I think so, yeah.
Alright. That makes sense. And then. Okay.
So we've ruled out one of the kinematic equations,
Yeah,
right?
It's not that one. We could do here. Alright, let's switch over. I could say change of x. Could do this other one. Let's try it out.
Mm-hmm.
Change of x equals the initial of t plus 1/2 a t squared.
Mhm.
Solve for t. Because I have my initial velocity and I know what my acceleration is. So
So you could use this to solve for t,
yeah.
except for the fact that you don't know delta x, because that's what you're trying to find here.
So these two wouldn't matter because I don't know t, I don't know this, which is
Right,
two
so you've
unknowns,
got one equation with two variables.
which doesn't
Right.
Another way I could do this. Let's just go to kinematics. I use two that don't work. So this one and that one does not work. So these two
Yeah,
don't work.
3 and 4 don't work. Yeah.
So I could try 2, which is my final. Those are the same. Divided by 2. Time. We don't know time.
Right.
So 2 doesn't work. V final equals V initial plus acceleration times time.
That would just tell us that v equals v,
Yeah.
and we couldn't solve for x because x doesn't show up.
So what I'm gonna have to do is make
So-
the equation to where, like how you said at the beginning.
Yeah, exactly.
And then
So
plug it
what
back
we're going to
into
need to
Y.
do is, because we don't know enough to solve for x using the x dimension, we'll need to use the y dimension to get time, then use time in the x dimension.
Okay, so for Y.
So now we're looking at the y dimension trying to solve for time.
Yeah.
So now we're trying to find this guy. And do we know acceleration in y?
Yeah, negative 9.8.
Yep. Do we know
Yeah, right,
initial
I need to-
velocity in y?
Here, I can hold it too.
Okay.
This negative 9.8. Final velocity in Y.
Well, do we know initial velocity in y?
Yeah, I
Mhm.
do know that.
Do we know the y distance traveled?
Yeah. We
Okay.
solved for that.
And what is it?
No, we don't know that. Because that was this. We solved for this.
Right.
We didn't solve for that.
However, it's already written on the picture.
It's 5.10.
Yeah.
Oh, okay.
Yeah.
Okay,
Because now,
so
since we have this as a starting point and this is
Yeah.
the ending point,
yeah,
the y distance is just the difference
it's just
between the two.
5.10. Okay.
So we actually do know this.
Yeah, so we do know that. Alright.
And even though we don't have velocity in y,
Yeah.
I bet we can find an equation that doesn't use it.
Cool.
I'm sorry, we don't have final velocity,
So we don't need to use that.
but I bet we don't even need it.
Yeah. Alright.
So can you find a kinematic equation that uses y, initial velocity in y,
Gotcha.
acceleration in y, and time?
Gotcha. So I'll do red. Change of y equals the initial of t plus 1/2 a t squared.
Mm-hmm.
And so then my distance in y is this right here. So
Mhm.
5.10 equals my initial velocity in my y direction. I didn't really solve for that.
True.
Yeah, I solved for my x,
Mm-hmm.
and then I used that to solve for that.
Right.
So I have to go back and solve for that.
Mm-hmm. It might help to draw the triangle again.
Yeah. So triangles like that. Okay, so you're doing that. This is your angle. That's my angle. You said x, vi of x is vi of y, and then this is vo.
Yeah, and so v
VO would
or,
be
yeah, or vo or vi, initial or
yeah,
that times 0, same thing.
yeah,
That would be the hypotenuse of the triangle.
yep.
So it'd be
So-
like this.
Got you. So, this is 53 degrees. Okay, so my V sub y would be V sub y, my initial velocity of y would be VO sine 53.
Mm-hmm. Yeah,
Yeah,
exactly. And you already know
VO.
this vo from
Yeah.
the previous problem.
So V sub y equals, here, I'll do this one down here because that VO is kind of a little bit thick. So
Okay.
let's go down here. So the initial of y equals my VO, which is it's
Oh,
right
you
here.
had it in the
It's
answer.
right
Yeah.
here. Yeah. 18.126983335 sine of 53 degrees.
Mm-hmm.
The sub y equals this in. I'll just copy and paste that. Control V, sine, 53 degrees. Equals X.
Cool.
And that equals 14 point. Okay, so 14.476525. Yeah, okay. So
Right.
then this is that. Plus 1/2. Erase that real quick. Plus my 1/2 negative 9.8, and then t squared. So you don't know time.
Yeah.
Okay, so
And so
it's negative 4.9 t squared.
at this point, we're probably gonna need to use the quadratic equation, or an online calculator or something.
Oh, yeah, because that is a t plus.
Yeah.
Plus 5.10. Okay.
Is it cool if I pause the video while we
Yeah.
run the numbers here and then start filming later?